So we solve it, gentlemen, as, see, there was option y, then 4 over 3y, then 3 over 4y, and 2y. You remember that question?
Yeah.
Right. I'm sorry that I made a mistake in that one. Somebody remind me on that, because I drive to math when I solve it. See, Shabab, this is correct, and I'm sorry. The answer, of course, it's y. When we say that Young modulus, it's something characteristic, it doesn't change. It remains always constant. No matter what's actually the properties of the matter you change, either radius, either length, or whatever. Just like, for example, we know that gravity for Earth, how much is it? 9.8. And we know that, for example, that for weight is equal to mg. So g is equal to F over m. You cannot say that this g depends on mass. So the mass increases, g will? No, this is not right. Because g is what? Constant. So I'm really sorry. I just write that one. I need to make it. The answer is y, because y is something characteristic for every material. So it doesn't change with changing of that. Is not that. So I told you from the I was drive by the mathematics to find the relation only. But if you think of it, just stop. No, I made a mistake in that question. So please, you just corrected me that. Okay. Today, inshallah ta'ala, we have the last here. Okay. Let's start with this one, inshallah ta'ala. See, first of all, if you remember, we talked about the energy in the first part. And we said, gentlemen, that the energy is related to the work. We said the work in general is equal to change in total energy of the system. That total energy includes, if you remember, we can say change in kinetic energy, change in potential, change in thermal energy, change in chemical energy, and extra, blah, blah, blah. Okay? Because E is actually shows what the total energy that we carry. Always we apply the same formula for it. Please just pay attention here. Allah yarda alaykum jami'an. So this is what I see. Now today we'll go a little bit deeper inside these parts. Kinetic and potential. When I say at the beginning, what is kinetic energy? You can answer with one word only.
Motion energy.
Just right. Kinetic energy is motion. That's it. It means, Yeshibab, here is related to the motion. The word motion means the object is moving. Whatever, no matter what type of motion is it. Is it linear? Is it rotation? It's circular? Simple harmonic motion? We don't care. Since the object is actually keep moving, that object has what we call by kinetic energy. Okay. Now, this kinetic energy is given by the formula. You remember the formula, gentlemen? Tell me. Half mv squared. Where m is the mass and v is the velocity that we have, or speed. Now, I need to say something also. Here, in physics mainly, gentlemen, we assume the mass is always constant. If you have any situation, any problem, if you have a ball, you throw that ball, through the whole problem, the ball is always assumed to be constant. It's not changing the mass. So in this one, we can say that kinetic energy depends on square of speed, like this one, not on the mass, because mass is assumed to be constant. So when I say it's not a speed, it's a square of speed. This means if the speed doubled, now the kinetic energy will quadruple, will increase by 4. If the speed tripled, it will increase by 9. Is that clear for you?
Yeah.
So the speed is really affecting the kinetic energy. Affected because the kinetic energy connected with the speed with a square of speed, not with the speed itself. واضح بارك الله فيكم? This is an idea. Now, I need to explain something before we proceed. Suppose we are talking about this one. We can write also, Shabab, as a special case that kinetic work is equal to change in kinetic energy. If we have only the kinetic energy change in our situation, okay? So instead of E, I'm going to replace with delta K. Suppose you have two cases, I will give you here. Suppose you have a car. That car is moving to the right. Now, it has a kinetic energy, I'm going to call Ki. The driver here actually pressed on the gas pedal. So there will be a force provided by the engine to accelerate the car, right? So this force will be in the same direction of displacement. This force I'm going of engine. Now, after some time, now the car is here. There will be another Kf, right? Because when we apply here, we apply the gas pedal, as I said, there will be a force and that force goes here. According to this, we know that Kf will be greater than, and we can say W, which is equal change in K, in this situation will be what? Positive. Because Z delta K is equal to Kf minus, and Kf already greater than, okay? This situation one. And ya shabab, W here, that work is positive. That means the energy of the object, which is or the system, which is the car, increases when you just press on the gas pedal. In the other situation, when you press on the brake, the driver now, he applies the braking. Now he's moving to the right again. The brake, where's the force now?
To the back.
Opposite direction. So the force would be here. We have force over brakes. Oh, now Ki. So the car will decelerate, and I know that here it will have a new kinetic, which is K final. The situation will tell us that K final is less than
K.
so W, which is equal to change in K, Allah Barik fikum. That's right, will be negative in this situation. And this means, Shabab, that here, that force doing a force that it decrease or minimize the energy of the car by atomic. Now, if I ask this question, this work, which used to minimize or to reduce the kinetic energy, will simply appear in the form of heat in the tires. Is that right? When you apply the brake, there will be some friction between the brake pads and the internal hub of the tire.
Yeah.
This friction causes some heat, and if you apply a sudden brake or a frequent blade in drifting, you know that the internal hub will become very hot. صح? All of us, we know that. So this is the idea that we talk about.
Except,
This is it. Yes.
so the kinetic energy will go the same sign with the
It
force.
will reduce. So the work will be negative.
Okay, so its sign is like the force sign.
No, the sign is for the work. For the work. Okay? Because we said, Yasha, work as a scalar, just a moment. As a scalar, we know that all the scalars are always positive. But we assume that the work sometimes positive, sometimes when the work is done by the system or in the system, or when the energy of the system increases or the system energy of the system decreases. نعم.
يعني لو كان الطاقة الحركية النهائية مع الطاقة الحركية البدائية نفس الشيء ما تغيرت السرعة.
There's no
راح يكون
work.
صفر.
صح. There's no work. For example, if you move with a constant velocity, you're not changing time, you're not changing direction or amount. So what happened? There will be no change. So there will be no work either by the engine or by the brake. You're not doing anything. صح? This is the idea. طيب يا شباب. Now let us continue this part. See, now here, of course, this kinetic energy is the object energy of motion. What happens to the kinetic energy of a car when it stops? It turns into thermal. We talk about this in tires between the hubs and the car brake pads. How you can increase the kinetic energy? By increasing
Force.
okay, from the formula by increasing the velocity. صح?
Yeah.
That velocity we need. Now we know that here, ya shabab, here the formula, W is equal to change in K, which is equal to Kf minus Ki. You can apply it for all situations that we have it. This is a car. Here, this is a simple car. I'm sorry, because here in this example, they mentioned when the car stops. Here, the car won't stop because the force in the same direction. So we assume that the car speed increases. So the kinetic energy will also increase. It's just a reason, just only to show you how it works. Now, this is simple. We have, gentlemen, here, that kinetic energy is given by half mv squared. Again, kinetic energy depends on the square of object's velocity, not on the mass. Because in all problems, we assume the mass of the object remains constant. طيب يا شباب. Let's go to this problem. And please read it carefully. We need somebody to answer this problem. You have two cars, one light plastic and the other one is heavy steel. This is your plastic cart, lighter one, and this is your steel cart. Both push with the same force. I'll put you some tips here. At a distance of
1 meter.
from rest. Okay? After the force is removed, the kinetic energy of the light plastic cart is that of the heavy steel cart. Greater, less than, equal, or we cannot say. انتبه معنا يا أسمح اترك الموبايل. Yes?
عوض بالقانون ان الستيل اثقل من البلاستيك.
اوكي.
الستيل 2 بالماس والماس حق البلاستيك نعطيه 1 ونعوض بالقانون.
طب ليش بدك تعطي اثنين؟ أنا ما ذكرت انهم اثنين واحد.
كان شوية ستيل وبلاستيك واحد.
كثير بس حكى we not mention anything.
المفترض
افترض. بس ليش الافتراض؟ We are not saying. I need to jump something يا شباب. You have another approach. Think of it. Yes.
في علاقة عكسية بين الحجم والسرعة.
بين الحجم.
والسرعة.
We're not talking about the حجم.
لا قصدي كتلة يعني بشكل عام يعني. كتلته.
كتلة والسرعة. طيب. You can prove it for us.
لا.
طيب. مش عارف.
Can't say.
You can't say. No, you can't say. Who's else? Zaid.
Greater.
You think it's greater now?
Yes.
If we remove force from both of them, then it's equal.
Okay, can you tell me just only equal?
Yeah, because if there is no force, then you can't apply the.
والله يا شباب.
Yes, down.
This is all your mistakes. You are not always read the question carefully. Just listen. We done Ahmed. See يا شباب. The answer will be equal. How is it? See يا شباب. خلينا نتكلم. First of all, they have the same force, right? They have the same displacement, right?
Yeah.
And both of them, their initial kinetic energy, how much is it? Because they start from rest. Okay? Let's try the formula. We know that the work is equal to change in kinetic energy. There's nothing. And it is equal to Kf minus. So this is 0, so work is equal to Kf. The work itself is equal to force times displacement. I will replace W by what? F times. Alright? See ya shabab. For the plastic cart, the same force and the same displacement. So they have the same final kinetic energy. And also the steel, they have the same thing. And we are asking, ya shabab, we are asking about the kinetic energy. Kinetic energy includes mass and speed. We're not asking about the speed, we are asking about kinetic energy. So the kinetic energy for both would be the same. All right, if I ask about the speed, no, the plastic will be faster. You see? I will prove it for you. Is that clear now, how they are the same? You should know what they are asked, because they ask the kinetic energy. Let me show you something. See, suppose their final kinetic energy is 50 joule. Suppose. We know that kinetic energy is equal to half mv squared, okay? Suppose this is 1 kilogram and this is 4 kilogram. I just made it because I did this before. See يا شباب. I will say half times 1 times 10 square. 10 square, how much is it?
100.
Over 2. Okay. Now this will be half times 4 times 5 square. 5 square, 25 times 4 over 2. Oh, if you compare, ya shabab, now you can see. This is a lighter, this heavier. Yeah, we assume this is 1 and this is 4. We're not assuming, we try to prove. Now the speed of this is different than the speed of this. But how much this one has energy and how much is this one? Both of them the same, even mathematically, right, ya shabab? Please, ya shabab, you need to read the question carefully before you just decide which is the correct answer. Inshallah واضحة لكم هذه الفكرة. طيب, we have another situation now. I will read it while you think of it. Each of the boxes shown is built with for 10 meters below, okay? Frictionless floor by the force given. Which box experiences the greatest change in the kinetic energy? It is? Right. Change in kinetic energy, that's down here, is equal to what? W. Is equal to what? F times D. So, they have the same D. This is constant. So this depends on what? Because all of them displace 10 meters. So as you said that, the answer will be D, right, 100%. No matter, don't care about the masses, ya shabab. They're asking about the whole package. They're not asking the details inside the package. When I say kinetic energy, I mean half times m times v squared. Okay? I mean just only the whole kinetic energy, regardless of the mass and the speed. Okay? So, ya shabab, here, you don't have just only watch the greatest force. You say change depends on two factors. It's force and displacement. Since all of them, they have the same displacement, so the kinetic energy change will be depends on the force. Right. This, inshallah, it's clear for you. Let's proceed. Now we will talk about the potential energy. Who can tell me what the word potential also means? We said kinetic motion. Potential also, one word.
Standing still.
Standing still.
Like over a hill maybe, or held. So as soon as you...
MGH.
I know, and that's it. But I need one word for it. You can say, here we say, for example, kinetic, we have motion, and potential without motion, equilibrium. Static, okay?
Height.
No, yes, well, you should know because I need this to get the potential. It means something stored. It's stored energy. That means, ya shabab, see it, sometimes in English we use the word. We can say, for example, Mishal, he got the required potential to do the job. It means there's something inside Mishal. You know it, that he has that motivation to do that job, only drinking coffee or something like that. But this we use it, this word, sometimes. When I say potential, it's something inside, right?
Yeah.
This is something inside. This is actually literature in English. In physics, we say that potential means something stored. Just like, for example, this eraser. When I say this eraser has a potential energy, can you see that energy inside it? No, it's already stored. You see, this is the idea. Now, that stored energy, according to that, we have two types of it. We have that energy stored due to its position, which is called by gravitational potential energy. Yes. I would say it's called UG. And we have, gentlemen, also elastic potential energy, which is called US. Let me show you something. Gravitational potential energy is simply due to the position from a certain height called by the here equilibrium or the zero level. We assume that the floor is the ground level, so its potential energy at the floor is zero. As you raise up, what happened to its potential energy? Increase. That's it. This is we have. Now, the potential energy for the object here, for example, in A, we assume that UGI is equal to 0. If we raise the object to B at a certain height, it will say UGF is equal to, say, 20 joule. So the work done will be change in, which is equal to 20 joule. Is that right? This is a situation that we have it. And the idea is what here is about, that potential energy depends mainly on height. That's why it is given from this formula, that UG is equal to mg h. Of course, h you can, in the textbook, they wrote it as yz. They are the same meaning. That's simple. And again, ya shabab, we are not talking about the mass. We assume the mass of the ball here is the same as the mass of the ball here.
Okay.
Always we assume it. So it's not changing. So we can say, yeah, that potential energy depends on, because these, we assume that these are both constant.
Yeah.
The mass is constant and also G is constant.
Yeah.
Okay, barakallah feekum. And, see, ya shabab, we know that potential gravitational potential, as you move away from the surface of the earth, your potential energy increases. As you move closer to the, or towards the earth, it decreases. This is, we know it. Now, in elastic, this potential energy, due to the shape or properties of the object, these elastic potential, some objects, we studied that, they have more degree of elasticity. For example, when you simply compress a spring, you apply a force and cause some displacements. So you do some work on it. And that work will transfer to inside the spring in the form of elastic potential energy. Yeah, shabab, see, we have a spring like this on the table. This is its equilibrium length. You compress. How do you compress? Simply you apply a force and you displace. Is that right?
Yes.
So in this position, now there is a work, and that work is nothing but equal to change in potential, elastic potential energy. Now, ya shabab, you remove your hand, what happened?
Goes back.
It will goes back.
Yeah.
So that energy already stored in the spring. And that spring, gentlemen, here we say that stored the energy, and you can retain that energy again. That's why we say that it is stored energy. This here, we have also a formula for it. Ya shabab, that elastic potential is given by half K delta X squared, where K is the spring constant, which is a constant, always. And delta X is the change in length. We know that X final minus X initial. This is K, we can find it from the slope. You remember that? From the Fx, if you have F and delta X, you can easily find the K from it.
This is the Planck constant.
Yeah, it's not Planck constant. It's that spring constant. Planck constant is H, by the way, it's not K. واضح يا شباب لكم? So this formula we use it for gravitational, and this formula we use it for elastic potential energy. Is that okay for you? Let's see the questions يا شباب. انتبهوا معي. I will read this as before, then I will explain something here. They mentioned here that the work done by the force against the gravitational force is transferred to the book as a gravitational potential energy. We have it. When you raise the book from this level to this level, we know that this is what happened. Now, yes, and we know, ya shabab, here that UG is equal to mgy. Y is the height. You can write Y, S, D, whatever is it. Since you know the meaning, this is what we care about it. Right. I have a notice here. We have just only something to explain. See, Ishra. We have two types of forces in this level. We need to explain them. We have some forces, they are said to be conservative forces. And other forces they call non-conservative. Conservative, محفوظة يا شباب. Non-conservative, غير محفوظة. see what happened. Forces that can store useful energy are called conservative. Yes, when you raise this one, this potential stored. I apply a force, I see, there's my force, make some displacement, and there is a work. That work transferred in the form of potential energy in the eraser. Right, ya shabab? Now this here, if you just simply, you can transfer into useful energy, we call it by conservative force. Now, some forces, just like friction, they are called non-conservative because they cannot store useful energy. Can you, for example, control the friction, ya shabab, here? You just convert the friction force to do another form of energy? No. No, you cannot do, ya shabab. Mainly the friction will appear in the form of heat, but heat is not that energy you can store or you can control. But that one, yes, you can control. And gentlemen, there's a formula here to find it easily for conservative. So please just notice that we have gravity, elastic, here they are called conservative because that force can store energy, and non-conservative because the friction as a force cannot store the energy. Okay? Now let's see this question. We have this scout, he's going to climb up the hill. That height is about 200 meters. Okay? We have here two positions. Tibu barakallah fik. You should know always here. In position 1 here, this person has a UG, how much is it? 0. In position 2, it becomes 160. Okay? This man has two options, either to follow path A or to follow path B. My question is, in which path the work will be greater? Path B. Path A, path B, or both are equal?
Path B.
Path B. It's a little bit, it's more steeper. Is that right?
No,
What?
no,
It's
no,
equal.
it's
It's equal.
Yes. يا شباب وصلنا من هالمشكلة. Work يا ابني here is equal to change in UG, right? Like change in UG will be UG final minus UG. According to this, 160 minus 0, and 160 minus 0 for both. صح? We don't care about the inside details يا شباب. So it will be for both 160 minus 0. So we have the same work, either for path A or path B. It's not the case of, don't look at the shape or the here. This is what we call by distraction. We give for the student. But if you are thinking logically, you have a formula, and that formula you can apply and you just prove it. And always I keep saying this word, Yeshua. To say something, you should convince yourself first to convince the others later. If you're not actually convinced in your opinion, you cannot transfer it to others. صح يا شباب؟ طيب. Another example, which is also a good example. We have two marbles, equal, identical marbles, Ahmed. First rolls down a steeper hill. This is the steeper. And they are here positioned at the same height. They have the same mass. This is steeper and this is less steeper. Now, both of them will reach the end of that incline, right? Now, what about which one will be faster? Yes, Ahmed.
same speed.
Why?
لأنهم ثابتين في الكتلة وثابتين في الارتفاع.
بارك الله.
فما في.
صح. Let me tell you something. Can we say here, يا شباب, UG1 is equal to UG2, right?
Yes.
And the whole UG1, it transfers into K, here, K1, and here K2. That potential energy transfer into kinetic, okay? Let's compare. We have here half m v squared, and here also half m v squared. Gentlemen, m is the same, right?
Yes.
So what about the v? Would be the same. Because K1 should equal, since UG1 is equal to, also K1 should equal
K2.
Okay, so this implies that they have the same speed at the end. Is that logic? Yes, logic, ya shabab, because here this is steeper. This will accelerate in shorter time, but this will take, but finally they will have the same speed. They will have the same speed, ya shabab. You got the point?
Yeah.
Right. If you have any question, ask me about this. Right, this is we talk about it. That potential energy, elastic, is given by half k x squared. We go, we know that how you compress the spring, everything. We go directly to the problem here. See, ya shabab, if you read the problem, we have this tendon at the back of your foot here. It's called Achilles tendon here. They give some idea. I will just here. The figure shows data for restoring force versus extension. Data is given for force and extension, delta x. Nothing there. Attached to muscle in female subject, what energy is stored in half centimeter stretch? When you move, that tendon keeps stretching to push you back, to actually will help us in that one. This tendon is very important. Now, they ask what energy? Energy, simple. US is equal to half K delta X squared, right?
Yes.
Delta X is already given. How much is it?
0.005.
Yes, of course you can 0.5 times 10 to the power negative 2 meter. So we need what? K. K, Allah yabarak fik. We just find by slope, which is slope, simple. You can take rise 400 over 0.24 times 10 to the power negative 2, because this is also centimeter. Times this by this square, you got what? That US. I told you from the beginning, sometimes it's about, you can find K. K is a constant. You find it from this graph, you can apply it in any other formula, because it's constant for the same spring. It's not changing. So always we apply it in this one. واضحة لكم هذه يا شباب? Is it okay? It's already solved for you, but this is a good question, really. Now we will talk about law of conservation of energy. See ya شباب. Now we will start from the following discussion. Just follow me. We know that delta E is equal to W, right? We know this is the total energy change is equal to nothing but the work.
Yeah.
We can simply write the delta E as a change in kinetic energy plus change in potential energy. You say gravitation plus change in elastic potential plus change in E thermal. I will explain this. All type of E equals. Right, ya shabab? Now, this change, we can write Kf minus Ki plus, UGF minus, and the rest. You send the I to the other side. Because negative, then other side will become positive. So we have, I will write like this here, Kf plus UGF plus USF plus, keep this as it is, equal Ki plus UG plus USI plus W. Nothing miss, right? W, which is the work. I send these, Mishal, we took this to the other side. Okay? It's negative.
The UGF minus UGI?
Yes, I send UGI there.
Like the.
That's it. We send it to the other side. Okay, Shabab?
What about A? What's A?
This one?
Yes.
Thermal energy. I will explain now. I will talk about this. See, ya Shabab, what the discussion say? For isolated system, we studied the isolate last time.
Yeah.
We always said that this term is equal to, for isolated. In isolated system, we said that there is no energy or work is exchanged in a system.
Yeah.
So that the work is zero. And if we assume there is no friction or the surface is completely frictionless, no thermal energy. So precisely, ya shabab, this is what happened. The sum of final energy should equal the sum of, and this is your conservation of, you would say that's follow. EF is equal to what? So delta E will be 0, right? Because delta E will be EF minus EI. Since they are equal, the change is 0. In this now, for an isolated system, always this is, we say the energy is conserved. That conserved mean the total energy, initial energy, should equal the total kinetic final energy. In this way, I know you took this in another form that energy cannot be created or destroyed, just change from. You're right, but this is something we have a formula to prove that. So you start always from this, that initial energy should equal. Ya shabab, in the problem sometimes they will give you only kinetic energy, so you consider it only. You skip the others. Sometimes they will give you kinetic and potential, gravitational. You consider both. Sometimes they will give you potential, kinetic, gravitation, and elastic. You consider all. Never mind, just like that. I will show you a problem now. This is the last point. See, Ishmael. This is the proof actually. This is what. I'll take it something easier than this. Look at the problem here, Ishmael. You solve it easier and you can apply the same concept for the whole problems. Just pay attention. تبقوا معي شباب. Why at the county fair Cathy tries to the water slide? يسموها زحليقة الماء يا شباب. Whose shade is shown in the figure? We have. The starting point is 9 meters above the ground. So already that Cathy, she has initial potential gravitational, right?
Yes.
It's 9 meters above. She pushes you off with an initial speed of 2 meters. So also she has a kinetic energy, initial, right? She's not starting from rest. Somebody pushed that girl. Now, how fast, of course, N is frictionless. You should know what is it. How fast will the Cathy be traveling at the bottom? We need VF. Here, UGF, how much is it?
0.
Because already the height is
0.
See, Yashab, always you can apply the following. When you say, delta E is equal to 0, means E initial should equal, this is conservation of energy. What type of energy we have?
Kinetic.
2 types, kinetic and, so you just write it, kinetic energy plus potential energy is equal to kinetic final plus potential. This we know that it is 0. Kinetic initial is equal to what? Half m v initial square. You follow that?
Yeah.
Plus m g h initial is equal to half m v final square. What about the mass? It's not given the question.
The same.
So what we do, we can cancel it. Like, that's perfect. We cancel the mass. Can I cancel also half with this half?
No.
Why?
You can't. Yes, you can't.
No.
It's not in all terms, Ashra.
Yeah.
Mathematics. We cancel mass because in all terms, 3 terms. Half is only how many terms? 2. You cannot cancel. You want to cancel, it should be, that term should be in all parts, in all terms, okay? You cannot cancel. So what is left here, Ashra? It's just only, you say half times 2 squared plus G 9.8 times 9. This is equals half times VF. You just find it and solve for what? VF. That's it. Wallahi shabab, you always start from this formula. Delta E 0. E initial is equal to E. And you do it. Nothing there.
Always.
Yeah?
Always.
Always, because always we assume that the energy is conserved. Right?
Even if you do
Yeah,
not
Shabab,
have
let me
this,
tell you something.
selected.
Why we assume that energy is conserved? We have a lot of details we have to take care about it. Imagine that there's something actually is rolling from a surface downhill. Okay? We can say that something is rolling. What is actually, for example, What about the surface? Whether it's rough and whether it is smooth? How much it's friction here? What about the winds at that time? What is about the shape of the object? Whether it's round object or something else? Many details you have to take care. صح يا شباب? No, we don't have the situation. Always when I say it's here, the energy is conserved, you say, oh, initial should equal. In real life, that not happen. In real life, we don't have that situation, ya شباب. But it's hard to measure all the factors affect that. When you drive your car, for example, ya شباب, suppose you have energy in your car, say 100 joules. You cannot control where that energy will dissipate. Yeah, Zaid, when you move, sometimes you have a bumpy road, sometimes good roads. Sometimes the winds will opposing you. Sometimes the winds will push you, right? Sometimes, ya shabab, you are moving up hills, keep moving, or you go down. Many details you have to take care of it. And maybe sometimes your tire is not working or not proper. Many details. So to skip all these, here we can say, so just what you do, okay, the energy is conserved. That means what is in should equal out. That's it. Okay? Allah يعطينا. We will stop here يا شباب. This is all of it for today. Thank you يا شباب. بس بدي أنا شايف يوسف السلمي مش موجود. هذا برضه الله أعلم إيش حكايته. في أحد ثاني غياب اليوم؟
حتى لو ما قالنا isolated.
لازم نقول لك ايزوليتد. طبعا ده نحن بنطبقه ايزوليتد. هو بقولنا بنطبقه على اساس انه ايزوليتد. في احد غير يوسف يا شباب؟
اصلا لو ما حط ايزوليتد ما بنقدر نحسبه بشكل دقيق.
ما بتقدر تحسبه بشكل دقيق. صحيح. الله يعطيك العافيه.